Hi, my name is Jay Wheaton. I'm a senior engineer working on robotics here at the Golisano Institute for Sustainability. For years, we've been using industrial robots and ABB to do an additive manufacturing technique called cold spray in a dusty environment. More recently, we've been using the universal robot, and it's on wheels so we can roll it around for different applications. And we have a third project planned where we are going to use an industrial robot for automated disassembly of electric vehicle components to try to gain some value back from used electric vehicles. So here we have our cold spray booth, and we have an industrial ABB robot in here that helps us take powder in and blast material down on the metal part, and it builds up layer by layer. But it does create a lot of particulate and metal dust in the air, so we have these large filters. So you have to be wearing a respirator in this room, but ideally you'll be outside of the room and the robot can handle this for you. It helps us create more consistent quality, better coatings, and process control as we research different techniques and methods. So some of our initiatives are really focused around adaptive path planning, so robots that aren't pre-programmed ahead of time, but they have some intelligence, whether it's computer vision or sensor feedback. And that ties into sensor fusion is what it's called, where we have several different sensors that are feeding data into the robot. It could be from other machines where it has to make decisions on the edge. The other piece that we're focusing on is integrating with other technologies. In this instance, we have a rotary table as well as a welder that is controlled by the robot. So this application specifically, we are working with an automotive manufacturer who repairs diesel components. So this is a diesel turbo housing which had a worn surface. It's an application where the welder has to be very skilled, and it's very labor intensive to go in, get the tip all the way in, and you have to very carefully build up the material to post-machine it. So they came to us looking for some help, and we came up with an application here where we 3D printed an end effector, and we mounted it to this rotary table, and we have an intelligent welder here. So the universal robot controls all of that. The tool is coming in and putting the tip deep inside of this bore here and building up material consistently, and it's building an arc as this turns and creates a spiral. And then that material can be post-machined after the fact to like new condition. And we can get really consistent welds and high quality, and we're able to successfully prove out and validate this process for the end customer. We have other applications where we've done picking up egg cartons and stacking them, and a lot of that ties into simulation. So we don't always go straight to hardware, but sometimes we go to simulation first. So you can see in the background here on this video, this is an example of NVIDIA's Omniverse platform, specifically Isaac Sim, where we can simulate a robot first, which is very useful in manufacturing. Rather than shutting down a production line, we can do the simulations, do the computer vision applications in robot development, and then deploy it and minimize the downtime at a manufacturer. So this is a photorealistic simulation. So this is a completely rendered environment, similar to video games or movies. So it uses Pixar's USD format in the background, which is what they use to make movies like Finding Nemo. It's a whole framework. It's NVIDIA's Omniverse framework. It's a physics engine behind the scenes, as well as computer vision and sensors. So what you don't see is this robot actually is getting synthetic sensor data. So it looks like a video is sending data to it, and it's making decisions exactly the same as it would on the floor. So you literally just change one line of code, and it'll be talking to this robot in the real world. As realistic as this is as good as this is going to be. So the more time you spend here, faster you can deploy the system in the real world. With this technology, it takes some time to get used to it. So we've spent several months. It might take years for someone to become proficient with the tools. Once you have that nailed down, it can really scale up and help you expand robotics in your manufacturing application. The other piece that we're working on is tools for decision makers in robotics. So sometimes you don't know where to start or where the best application is. So we've developed a website where manufacturers can go on and they can put in their information, and it'll help show you the different payoff and difficulty with various robots for your application. If you're interested in working with us on these technologies, feel free to check out our website and reach out to the Center of Excellence here at Golisano Institute for Sustainability.